Okay, so everything for chi-squared test for goodness of fit was a one-way table. It was a one variable. So now we're going to a two-way table where you have two variables, and they're two different types of tests. One we'll do today, and one we'll do next week. The hardest part about this one is knowing how to pronounce that. This is a chi-squared test for I don't think anybody said it yet. Homogeneity. Homogeneity. Okay. If we are homogeneous, what does that mean? We are the same. Okay. So your H sub O is going to be always that there is no difference in the distribution of a categorical variable for several populations or treatments. Will not change. You'll adapt it for your particular problem. Okay, so I want to know, I think 20% of men favor pepperoni pizza and 60% of women favor pepperoni pizza. How many populations do I have? Two. I have two populations. But what am I concerned about? How many variables am I concerned about? Pepperoni pizza or not. So one variable. So I have one variable, but two populations, and that's what sparks the two-way table. So H sub O is saying what about pizza? Be more specific. Be more specific. There you go. There's no difference in the preference for pepperoni pizza between men and women. It's going to be the same percent for both. So your alternate is that there is a difference. Okay, now this is new. Expected counts. You take your row total times the column total and divide it by that bottom corner number, which is the table total, which we shall practice. That's how you find your expected counts. Your conditions, I have to be random, independent. Why are there two? Because I have two populations. LCC, all expected values must be at least 5. That's all the same. Chi-squared, exactly the same. Find and compute it on the calculator, but they, AP readers, want you to show them a few steps of the calculation. We talked about that earlier. Give them a couple at the beginning, a little dot, 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 and then the guy at the end. P-value is exactly the same. It's still a chi-squared. That's all the same. This is different. Degrees of freedom is the number of rows minus 1 times the number of columns minus 1. No, I have 500 females and 400 males. Oh, sorry. Yes. What if I had freshmen, sophomore, junior, seniors? So 4 would be 3. And then pizza or no pizza, so that'd be 1. So 3 times 1. Okay, so guys, tell me what's different. What are we adjusting for? What's different than what you just took your quiz on? Expected counts. Okay, so he's new. What else? Say it again. Okay, yeah, I agree. Those are different. And your degrees of freedom. Those are the big changes. Okay, and what is this called again? Good, a chi-squared test for homogeneity. And then when you trying to think about it, it's are the two populations the same, homogeneous, or are they different? Okay. Does background music influence what customers buy? Market researchers suspect that background music may affect the mood and the buying behavior of customers. One study in a European restaurant compared 3 randomly assigned treatments: no music, French accordion music, and Italian string music. Under each condition, the researchers recorded the number of customers who ordered French, Italian, and other entrees. Here's a table that summarized the data. So, like, tell me what that number means. They were listening to Italian music and they ordered Italian food. Whereas this person listened to French music but ordered Italian food. So they're trying to see if there's a difference here. So we're going to do a chi-squared test for homogeneity. Here's your H sub O. There is no difference. Music makes no difference whatsoever. Do y'all see that? Music makes no difference. There's no difference in the true distribution of entrees ordered at this restaurant when no music, French accordion music, or Italian string music is played. It makes no difference. And H sub A, the exact same thing, just take out the word no. I hereby declare that my alpha is 0.05. Conditions, random. I did not randomly select people. These people came to this restaurant. I didn't tell them to come to this restaurant. What was the randomness? Yes, because they came into the restaurant and we figured out which music we were going to play. We predetermined that. Why do I not need to worry about being independent? I didn't take a random sample. LCC, all expected values are at least 5. I can write that. I haven't figured that out yet. Here we go. These are my observed counts. These are my expected counts. Help me figure out where these come from. What's the formula for expected counts? Row total times column total over total total. Okay, so if I'm trying to figure out this number right here, what is that spot's row total? Okay, so I'm doing 99. Okay, what is that spot's column total? What is your total total? What's going to be the same for each one? The 243. So check me. 99 times 84. Every one. It's a pain in the butt. Did we get it? Now, I'm a huge proponent of 3 decimal places, but guys, you're going to have 9 decimals in here, all to 3 decimal places. And because you don't want to rewrite the chart, this is what I recommend you do. Just write it beside it. So when I do this, I go 1 decimal place. Okay? You are writing the formula, and that's all you have to do. You don't have to show it for every single one of these, but you have to write out the formula. You're going to write, where do you? That. You're going to write that, and then you're going to do it. But you don't have to show the numbers for every single one of them for the process. No, they don't expect you to show your work for that. Okay, once I have all my expected counts, then I'm going to find my chi-squared. Normally this is where I go L1, L2, and type my formula into L3. But you have to show a few by hand to show them, to communicate to them that you know what you're doing. So a chi-squared test, or chi-squared, is going to equal sum observed minus expected squared over expected, straight off your formula sheet. Then, here's the weird thing. It doesn't matter the order in which you go, guys. You can go across or you can go down. It doesn't matter. It all goes into your L3. It all gets summed. So they went 30 minus 34.22 squared divided by 34.22 plus, and then they decided to go this way. So 39 minus 30.56, and then plus, and then dot, 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 and then they go do the bottom corner. So they're showing 2 at the front, dot, 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 process repeats, and then you show the very last one. Okay? Then you go to your calculator. Grab your calculators. And you're going to type all your observed into your what? L1, your expected into your L2. Make sure they line up. Type your formula in to your L3 and see if you can get this. Okay, so our next step is to find our p-value. So we're going to draw our curve with a backbone, right skewed, always right tailed, to find our degrees of freedom. Degrees of freedom are normally what? Normally n minus 1. For chi-squared test of goodness of fit, your degrees of freedom are categories minus 1. For a chi-squared test of homogeneity, because you have a two-way table and you have to write this, number of columns minus 1, number of rows minus 1. And I have 3 columns and 3 rows. Don't count your totals. So that's going to give me degrees of freedom of 4. Some chi-squared CDF from our chi-squared value to infinity. Degrees of freedom, that's a 4. I get this cute little baby p-value. Oh boy. Let's interpret the p-value, shall we? It's our favorite thing. All right. It's right there. Interpreting the p-value. Assuming that there is no difference in the true distribution of entrees orders in this restaurant when no music, French according music, or Italian string music is played. What did I just state? H sub O. There is a 0.00109 probability of observing a difference in the distribution of entrees ordered among the 3 treatment groups as large or larger, because I'm right-tailed, the one in this study. Now, normally this is where I put a number. Y'all are super awesome at that, but this is normally where you put a number. Where do you get that number from? Right. Your 2 sample statistics, you subtract them. I don't have sample statistics here. So that's the best I can do, because I can't get a number there. So, assuming what? Because I'm right-tailed. So it's for this or bigger. It will never be less than, because my chi-squared is always here or greater than. Always right-tailed. Okay, so assuming what? What do I start with? My H sub O. My exact word for word H sub O. There is a, where do you get that number? That's your p-value. Probability of what? observing a difference between this and this as large or larger than the one in this study. How are you going to get good at doing this? Practicing it on your homework. Okay, then we have this cute little conclusion. Because our p-value is tiny and smaller than the level of significance for this test, we reject H sub O. Our evidence statement is always about H sub A. There is enough convincing evidence to conclude that there is a difference in the two distributions of entrees ordered at this restaurant when no music, French accordion music, or Italian string music is played. Furthermore, the random assignment experiment allows us to say that the difference is caused by the music that's played. Why can I drop that word caused? Because it's an experiment. That's why. Okay, let's try one. And this is it. This is the last one we're doing today. Because then it goes into the third test, which we're going to do next week. Say it again. Yeah, it's a chi-square test for independence. Okay, here we go. The Pennsylvania State University has its main campus in the town of State College and more than 20 smaller Commonwealth campuses around the state. Does that remind you of the UNC system? No? So what's the UNC mothership school? Chapel Hill. And then you've got UNC Pembroke and Charlotte and Greensboro and Wilmington, Asheville. Those are all the little baby schools, where Carolina and Chapel Hill is the mama. And then you've got, that's what this is. Pennsylvania State University has its main campus, and then it's got these little offshoots, and that's what all those other schools are. They are part of the UNC system for schools. The Penn State Division of Student Affairs polled a separate random samples of undergrads from the main campus and the Commonwealth campuses about their use of online social networking. Facebook was the most popular site, with more than 80% of students having an account. Here's a comparison of Facebook use by undergrads at the main campus and Commonwealth campuses who have a Facebook account. Tell me this. How many variables do you have? What do y'all think? Connor thinks 2. Anna, you said 1. Iffy. You stick with it? Oh, don't know. How many variables? What are you measuring? Okay, so how many variables do you have? One. Guys, you're just measuring Facebook use. That's it. That's all I'm measuring. Now, what's the deal with the main campus versus the Commonwealth campuses? Those are your 2 populations. That's not a variable. Those are your 2 populations. So I have a 2-way table because I have population number 1 and population number 2, and this is my variable. Does this data provide convincing evidence, so I know I'm doing a test, of a difference in distributions of Facebook use among students at the 2 campus settings? So I'm looking to see if the 2 campus settings are homogeneous or if they're different. Okay. What's the name of our test? I spell that right? Yeah, whatever. H sub O.
There is no difference in the
Facebook use.
based on where you live.
Uh, mm, but be specific about the campuses.
But the campus.
Commonwealth. All right, H sub O. H sub O. I'm going to type. All right, how are we starting? There is no difference. Everybody start there. I need a word. What's a word that we, thank you. True distribution of Facebook use. Oh, I should capitalize Facebook. Okay. Mm-mm. There is no difference in the true distribution of Facebook use, that's the variable that I'm studying, between my two populations, students at the main campus versus students at the Commonwealth campuses. I don't see a big push for the word all here. True, yes. I don't think it would hurt to put the word all in here. To be consistent, you can do that, so you don't have to try to remember. And then what's your, there is a difference. Well, no. Okay, what else do we need to establish right here? Level of significance.
Then you need to go to your conditions. You should always go to your conditions.
Yes, technically you should. I can't ever remember that. I go straight into my conditions, and when I get to that sentence about expected counts, then I pop back up and do my, because, I mean, I'm just being real about, like, when I do these problems, after that, I always go straight to my conditions, and when I write that for my LCC to be normal, that's when I pop back up and do that. All right, conditions. What's the first one? Okay, now the last one was random treatments. Bless you. Bless you again. Pulled a separate random sample. Check. Okay. In, oh, struggle. Independent. Yes, I do. I have two samples. So N sub 1, big N sub 1, and N sub 2. Yeah. Well, it's in the table. How many you got on the main campus? 910. 1/10 of what? Technically, in the state of Pennsylvania. I really feel like that's implied, but we've been such a stickler for, in this election, that kind of stuff, in this city. So I'm just going to put in Pennsylvania. All right, how many of the other sample size we got? All undergrad students at Commonwealth campuses in Pennsylvania. I'm going to do what? All expected counts greater than or equal to 5. And I'm going to put a check mark, but that's going to remind me, oh yeah, I got to go find them. So then I'm going to creep back up here. But then I'm going to think, okay, wait, hold on, I'm using a formula. If I'm going to use a formula, I need to write that formula down. So I'm going to come back down here and I'm going to write expected counts equals. How do I find it? Row total, column total, okay. I think either is okay. Tote. I think just write total. Okay, so let's find expected counts for this guy. Ooh. I've got my Facebook totals. Or my campus totals. I don't have my totals over here. Can we add these together? What is that? 131? 2633 72 1310 34. Ooh, check me on that one. Yes. And then 1537. Is that right? Make sure you get your total right, because that's used in every single one of them. Okay, so how do I find this? 131 times 910 divided by 1537. All right, rock on. Keep going. Y'all want to say we're going to go 2 decimal places? Your expected counts should be in the ballpark of the observed. Okay, once you're there, what's next? L1, L2? What do I write next? My chi-squared. What's the formula for him?
The sum of your observed minus expected squared over your expected.
And then what painful thing do I have to do on paper? I got to give 2 at the beginning, little dot, 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 and then 1 at the end.
Catfish. So they kept saying, this is the meow fish. She thought it was so funny. Everybody in the line was laughing at her. I was like, what is she doing?
For my chi-squared, I got 19.49. Is there a 0 after that?
It's 19.48951272.
So yes, there's a 0. Thank you. Does chi-squared ever have units of measurement? It's like a distance. Yeah. Okay, so once you're good and you got your chi-squared, what's next? B-value. 0.49.
Can go from 19.490 0 degrees of freedom. Remember, don't forget. I don't remember the formula. It's what? No, it's number of rows.
No, you're fine to do this.
Hey, that's actually kind of close to where we are with this.
Okay. Write your conclusion. Like, go big. This ain't like, get it? Perfect. Your conclusion. This is it. This is where we finish. So finish strong. Did we put him up there with our H sub O and H sub O? Parentheses. Yeah.